Right now, millions of children around the world are having their neural architecture permanently altered, not by disease, not by accident, but by something we consider maturity. What if I told you that the responsible child may actually be showing signs of neurological damage? In the next few minutes, I'll share evidence from brain scans that will fundamentally change your view of child development. You're about to discover how parentification, when children become caregivers to their own parents, doesn't just steal childhood joy, but literally rewires the developing brain in ways that can last a lifetime. If you work with children, are a parent, or simply care about the next generation's mental health, hit that like button right now. This information needs to reach every adult who influences a child's life. Subscribe because I share cutting-edge brain science that can literally change lives every week. Let's dive into the neuroscience that's rewriting everything we thought we knew about childhood. We need to start by exposing an invisible epidemic hiding in plain sight: parentification. And you've probably witnessed it without even knowing what you were seeing. Picture Tommy, age 9, who sits between his fighting parents every night, trying to negotiate peace like a tiny United Nations diplomat. Or Sarah, 8 years old, who knows exactly how much money is in the family checking account and feels guilty asking for school supplies. Then there's Marcus, 10, who has perfected the art of making dinner, helping with homework, and putting 3 younger siblings to bed while his single mother works her 3rd job of the day. These aren't just mature kids. They're children trapped in a role reversal that's rewiring their developing brains in real time. Parentification occurs when the fundamental parent-child dynamic flips upside down. The child becomes the caregiver, the problem solver, the emotional regulator for adults who should be providing those services to them. It's not about teaching responsibility. That's healthy. This is about survival adaptation that forces neural development down unnatural pathways. Research from the American Psychological Association reveals that 1 in 3 children globally experience some form of parentification before age 12. But here's what makes this epidemic invisible. These children often look like success stories from the outside. There are 2 distinct types, each creating different neural signatures. Instrumental parentification involves physical caregiving, cooking, cleaning, managing household finances, caring for siblings or even parents. Emotional parentification is more insidious. The child becomes the family therapist, mediating conflicts, managing everyone else's emotional states, carrying secrets too heavy for their developing minds. Both types share a common thread. They force the child's brain to prioritize survival and caretaking circuits over the neural networks designed for exploration, creativity, and age-appropriate development. What makes this particularly devastating is how society rewards it. We praise the little adult, celebrate their wisdom beyond their years, admire how they never cause problems. Meanwhile, their brains are adapting to chronic stress by fundamentally altering their neural architecture. The child's developing prefrontal cortex, their executive control center, gets hijacked into overdrive mode, while crucial social and emotional development circuits remain underdeveloped. It's like forcing a computer to run adult software before the operating system has finished installing. Unlike normal childhood challenges that build resilience, parentification creates what neuroscientists call toxic stress. Stress so overwhelming and persistent that it damages the very systems designed to cope with stress. But here's where it gets truly fascinating from a neuroscience perspective. The human brain is so remarkably adaptable that it will sacrifice optimal development to ensure survival. And to understand just how profound these sacrifices are, we need to first understand what healthy brain development actually looks like. To grasp the devastating impact of parentification, we first need to understand the miraculous process of how a child's brain naturally constructs itself. Think of it as the most sophisticated smart building ever designed, with automated systems that must come online in precise sequence. When a baby is born, they possess approximately 86 billion neurons, nearly the same number as adults. But here's the fascinating part. It's not about the raw materials, it's about the connections. A newborn's brain contains roughly 2,500 synapses per neuron. By age 3, that number explodes to 15,000 synapses per neuron, more neural connections than they'll ever have again in their lifetime. This process is called synaptogenesis, and it follows a carefully orchestrated timeline that cannot be rushed without consequences. The brain essentially builds itself from the ground up, like constructing a city with districts that must develop in specific order. The first district to come online is the brainstem, our survival headquarters, managing breathing, heart rate, and basic functions. Next comes the limbic system, our emotional processing center, which develops rapidly in the first 3 years. This includes the amygdala for threat detection and the hippocampus for memory formation. But here's where it gets crucial. The prefrontal cortex, our executive control center responsible for decision-making, impulse control, and abstract thinking, doesn't fully mature until around age 25. It's literally the last construction zone to finish. During healthy development, children's brains are designed to operate in what neuroscientists call exploration mode. When a child feels safe and protected, their nervous system activates the parasympathetic branch, the rest and grow system. This allows maximum energy investment in building new neural pathways through play, curiosity, and age-appropriate challenges. Play isn't frivolous, it's precision brain engineering. When children engage in pretend play, they're literally constructing theory of mind networks, learning that other people have different thoughts and feelings. When they play peekaboo, they're building object permanent circuits. When they stack blocks and watch them fall, they're developing cause and effect reasoning pathways. The default mode network, a recently discovered brain system active during rest, develops its mature connectivity patterns through daydreaming, imagination, and unstructured time. This network is crucial for self-reflection, creativity, and mental health throughout life. Mirror neurons, discovered in the 1990s, fire both when we perform an action and when we observe others performing the same action. In children, these neurons are hyperactive, constantly learning social behaviors, emotional regulation, and communication patterns from the adults around them. The attachment system serves as the foundation for all other development. When children experience consistent, attuned caregiving, their brains develop secure internal working models of relationships. The orbitofrontal cortex, which connects emotional and rational brain regions, literally grows larger and more integrated in securely attached children. Critical periods, or sensitive windows, represent times when specific neural circuits are most plastic and responsive to experience. The visual system has critical periods in early infancy. Language development has critical periods in early childhood. Social-emotional development has critical periods throughout childhood and adolescence. What's remarkable is how the healthy developing brain maintains perfect balance between stability and plasticity. New experiences literally sculpt neural architecture through a process called activity-dependent plasticity. Neurons that fire together wire together. But this beautiful, precisely timed developmental symphony requires one non-negotiable condition. The child must feel fundamentally safe and cared for. Their developing nervous system needs to know that survival is handled by competent adults, freeing up precious neural resources for growth, learning, and joy. When that safety is compromised, when survival becomes the child's responsibility, everything changes. The brain's construction project gets derailed in ways that will shape every aspect of their future life. Now we arrive at the devastating reality of what happens when that carefully orchestrated brain construction gets hijacked by survival demands. What you're about to learn represents some of the most alarming findings in developmental neuroscience. When a child enters parentification, their brain essentially declares a neurological state of emergency. Ancient survival systems, designed to help our ancestors survive immediate physical threats, suddenly take control of modern developing minds that should be focused on learning and growth. The salience network, your brain's alarm system, becomes hyperactivated. This network, which includes the anterior insula and dorsal anterior cingulate cortex, is supposed to help us notice important information in our environment. In parentified children, it's constantly screaming danger even when there's no immediate physical threat. This triggers a cascade of neurobiological changes that would be appropriate for a child fleeing a predator, but devastating for a child trying to develop normally in modern society. The hypothalamic pituitary adrenal axis, our stress response highway, shifts into permanent overdrive. Here's where the neuroscience gets truly disturbing. Cortisol, our primary stress hormone, becomes chronically elevated. Studies using functional MRI scans show that parentified children have cortisol levels up to 400% higher than their peers. But cortisol isn't just a hormone. It's a neurotoxin when present in excessive amounts over extended periods. The first casualty is the hippocampus, our brain's memory consolidation center. Chronic cortisol exposure literally shrinks hippocampal volume. Brain imaging studies reveal that children experiencing chronic parentification can have hippocampi up to 25%, smaller than age-matched controls. This isn't just concerning, it's tragic. We're talking about permanent structural changes to the brain's learning and memory systems. But the damage doesn't stop there. The developing corpus callosum, the bridge connecting the brain's two hemispheres, shows reduced white matter integrity under chronic stress. This means the left and right sides of the brain can't communicate as effectively, impacting everything from emotional regulation to creative problem solving. The default mode network, which we discussed as crucial for self-reflection and creativity, becomes fragmented. Instead of developing healthy introspective capabilities, parentified children show disrupted connectivity patterns similar to those seen in adults with trauma disorders. Their minds literally lose the ability to rest and reflect. Perhaps most devastating is what happens to the developing attachment system. The orbitofrontal cortex, which should be learning to form secure relationships, instead develops hypervigilant patterns. These children's brains become wired to constantly scan for emotional threats and caretaking opportunities rather than developing healthy reciprocal relationships. From an evolutionary perspective, these adaptations make tragic sense. Our brains evolved over millions of years to prioritize immediate survival over long-term thriving. When a child's environment signals chronic threat or instability, the brain makes a calculated sacrifice. It abandons optimal development in favor of survival adaptation. The amygdala, our fear center, becomes enlarged and hyperreactive. Neuroimaging studies show that parentified children have amygdalae that fire more intensely and more frequently than healthy controls. They develop what researchers call threat superiority effect. Their brains become biased toward detecting problems, dangers, and needs in their environment. Meanwhile, the ventral striatum, associated with reward and pleasure processing, shows reduced activity. These children's brains literally lose the capacity for age-appropriate joy and spontaneity. Play circuits remain underdeveloped because neural resources are constantly diverted to survival and caretaking systems. The developing social brain networks also suffer profound disruption. Areas like the temporoparietal junction, crucial for understanding others' mental states, develop atypical activation patterns. These children become experts at reading others' emotional needs, but struggle to identify their own. Chronic activation of the sympathetic nervous system, our fight or flight response, creates a state of neuroinflammation. Pro-inflammatory cytokines flood the developing brain, further compromising neural development and creating vulnerability to autoimmune conditions later in life. The circadian rhythm system, controlled by the suprachiasmatic nucleus, becomes dysregulated. Parentified children often show disrupted sleep-wake cycles, further compromising brain development since most neural repair and consolidation occurs during deep sleep. Perhaps most tragically, these neurological changes create epigenetic modifications, changes in gene expression that can be passed to future generations. The stress of parentification literally alters the genetic instructions these children will pass to their own offspring. Research from Harvard's Center on the Developing Child shows that toxic stress in childhood creates what they term biological scarring, measurable changes in immune function, cardiovascular health, and brain architecture that persist throughout life. But here's the critical question that keeps researchers awake at night. Are these changes permanent? Can a brain that's been rewired for survival ever learn to thrive again? The answer will determine the fate of millions of children worldwide. The neurological adaptations we just explored don't simply disappear when these children reach adulthood. Instead, they become the invisible architecture shaping every aspect of their adult lives, creating what researchers call the neurological legacy of childhood parentification. The Adverse Childhood Experiences Study, following over 17,000 participants for decades, revealed stunning findings about adults with parentification histories. But it's not just the statistics that are shocking. It's the specific ways their brains continue operating in survival mode decades later. Take hypervigilance, the constant scanning for threats that served them as children. In adults, this manifests as an inability to truly relax. Their anterior cingulate cortex remains in a state of heightened activation, constantly monitoring their environment for problems to solve or people to rescue. They're the adults who notice every micro-expression of distress in a room, who can't enjoy a vacation because they're mentally managing everyone else's experience. The attachment system, disrupted in childhood, creates a specific neurological signature in adult relationships. Brain imaging studies show that adults with parentification histories have altered activity in the ventral tegmental area and nucleus accumbens, brain regions involved in bonding and reward. They literally experience love differently, often confusing being needed with being loved because their neural reward systems were wired during caretaking, not receiving care. Perhaps most devastating is what happens to their stress response system. The hypothalamic pituitary adrenal axis, chronically activated in childhood, develops what researchers call allostatic load, essentially the wear and tear of chronic stress on the body and brain. Their baseline cortisol levels remain elevated, their inflammatory markers stay high, and their telomeres, protective DNA caps, are significantly shorter, effectively aging their cells faster than their chronological age. The prefrontal cortex, which should have developed executive function skills through play and exploration, instead learned hyper-responsibility and anxiety-driven decision-making. These adults struggle with what neuroscientists call cognitive flexibility, the ability to shift between different mental tasks or adapt their thinking to new situations. They become rigid in their need to control and manage outcomes. Their default mode network, crucial for self-reflection and identity formation, shows persistent connectivity issues. Many adults with parentification histories report feeling like they don't know who they are outside of their caretaking roles. Neuroimaging confirms this. Their self-referential brain networks remain underdeveloped compared to adults who had protected childhoods. The most tragic manifestation is in their relationship with pleasure and spontaneity. The ventral striatum and associated reward pathways, understimulated during childhood play, remain sluggish in adulthood. These individuals often describe feeling guilty about rest, unable to enjoy leisure activities without feeling like they're being selfish or lazy. Their brains literally haven't developed the neural pathways for guilt-free enjoyment. Chronic neuroinflammation from childhood stress creates vulnerability to autoimmune conditions, cardiovascular disease, and metabolic disorders. Studies show that adults with parentification histories have 2.5 times higher rates of autoimmune conditions and live an average of 8 years shorter than those with protected childhoods. But perhaps the most insidious aspect is the intergenerational transmission. Epigenetic changes from childhood stress alter gene expression patterns that get passed to their children. Even with the best intentions, parents with parentification histories often struggle with appropriate boundaries because their mirror neuron systems learned caretaking rather than healthy reciprocity. Their nervous systems remain dysregulated, often swinging between hyperactivation, anxiety, perfectionism, people-pleasing, and hypoactivation, depression, emotional numbness, burnout. This isn't a character flaw. It's a neurobiological consequence of childhood survival adaptations. The workplace often becomes another arena where these patterns play out. They become the employees who can't say no, who work themselves into burnout, who feel responsible for everyone else's performance. Success addiction becomes their drug of choice because achievement temporarily activates their underdeveloped reward systems. But there's hope hidden in this neurological landscape. The same plasticity that allowed these devastating adaptations also holds the key to healing. Now comes the critical question. How do we identify when a child's brain is being rewired by parentification? The answer lies in recognizing specific neurological signatures that manifest as observable patterns in behavior, physiology, and cognition. Unlike traditional behavioral checklists, we're looking for brain-based indicators that reveal dysregulated nervous systems operating in chronic survival mode. The first signature is hypervigilance masquerading as maturity. Watch a parentified child's eyes. They dart constantly, scanning faces for emotional distress, monitoring adult conversations for problems to solve. Their pupils often remain slightly dilated, a sign of chronic sympathetic nervous system activation. Their posture reflects this too, shoulders slightly raised, ready for action, never fully relaxed. Sleep architecture provides crucial neurological evidence. These children show fragmented REM sleep patterns because their stress-activated brains can't achieve the deep rest necessary for memory consolidation and neural repair. They're often night worriers, lying awake processing adult problems their developing brains shouldn't be handling. Their attention patterns reveal divided cognitive load. While age-matched peers show focused attention during play or learning, parentified children display what researchers call split attention syndrome. Part of their cognitive resources constantly monitor their environment for caretaking opportunities, leaving less mental bandwidth for age-appropriate tasks. Physiological markers are equally telling. Chronic cortisol elevation affects growth patterns. These children often show early puberty onset as stress hormones disrupt normal developmental timing. Their immune systems become dysregulated, leading to frequent illness or, paradoxically, rarely getting sick because their stress hormones suppress normal immune responses. The most subtle yet profound signature appears in their social brain functioning. Mirror neuron activation patterns show they're constantly reading others' emotional states, but struggle to identify their own internal experiences. They can articulate exactly what everyone else needs, but remain puzzled when asked about their own feelings or desires. Academic performance presents interesting paradoxes. Many excel at tasks requiring responsibility and rule following, but struggle with creative assignments or open-ended exploration. Their prefrontal cortex, overdeveloped for control and planning, lacks the flexible thinking that comes from play-based learning. For adults wondering about their own histories, specific neurological patterns persist. Do you experience physical anxiety when others are upset, even strangers? That's your anterior cingulate cortex, still hyperactive from childhood hypervigilance. Do you feel guilty during leisure activities? Your reward pathways were shaped by caretaking, not receiving care. Body-based assessment reveals crucial information. Adults with parentification histories often show chronic muscle tension in shoulders and jaw, physical manifestations of decades-old threat detection systems. Their breathing patterns tend to be shallow and chest-focused rather than deep and diaphragmatic. The most reliable indicator is the nervous system's response to boundaries. When someone tries to care for them or says, "That's not your responsibility," they experience physical discomfort, racing heart, sweaty palms, restlessness. Their brains interpret receiving care as danger because survival was earned through giving care. But recognizing these signatures is only the beginning. The real question is, what do we do with this knowledge? Here's where neuroscience becomes our greatest ally. The same neuroplasticity that allowed parentification to rewire developing brains also holds the key to healing. We're not just talking about behavioral changes. We're talking about literally rebuilding neural architecture. The foundation of all intervention is nervous system regulation through co-regulation. When a dysregulated child interacts with a calm, regulated adult, their mirror neurons begin copying the adult's neural patterns. This isn't metaphorical. It's measurable through EEG studies showing brainwave synchronization between regulated caregivers and children. Start with vagus nerve strengthening. The vagus nerve is your body's primary rest and digest pathway, often compromised in parentified children. Simple interventions like humming, singing, or gargling literally tone this nerve by activating muscles connected to vagal pathways. Cold water face splashing triggers the dive reflex, instantly shifting the nervous system from sympathetic to parasympathetic activation. Rebuilding play circuits requires intentional neuroplasticity interventions. The brain's play systems, centered in the periaqueductal gray and associated with dopamine release, need deliberate reactivation. This means scheduling neural play breaks, times when the child engages in purposeless, joy-based activities without any learning objectives or performance metrics. Somatic interventions target the body-based aspects of trauma. Techniques like progressive muscle relaxation specifically address the chronic muscle tension patterns we discussed. But more advanced approaches like somatic experiencing help children learn to track internal sensations, rebuilding interoceptive awareness, the ability to feel what's happening inside their bodies. Eye movement, desensitization and reprocessing, EMDR, has shown remarkable results in rewiring trauma-affected brains. During EMDR, bilateral stimulation activates both brain hemispheres simultaneously, helping integrate fragmented memories and reducing amygdala hyperactivation. Brain scans show measurable changes in neural connectivity after successful EMDR treatment. For emotional regulation, we need to rebuild the connection between the prefrontal cortex and limbic system. Mindfulness practices adapted for different developmental stages literally strengthen these neural pathways. But it's not just sitting meditation. It includes mindful movement, art therapy, and nature-based mindfulness that engage multiple brain networks simultaneously. Creating safety signals for the nervous system involves environmental neuroscience. Parentified children's brains are constantly scanning for threats, so we must create consistent environmental cues that signal safety. This includes predictable routines, physical spaces that feel contained and cozy, and sensory inputs that activate parasympathetic responses like soft textures, warm lighting, and calming sounds. Professional therapeutic modalities offer targeted neural interventions. Play therapy isn't just fun, it's precision brain rehabilitation, helping rebuild neural networks that were sacrificed for survival. Sand tray therapy engages both conscious and unconscious processing, allowing the brain to reorganize traumatic experiences through symbolic representation. Internal family systems, IFS therapy, addresses the fragmented sense of self common in parentified children. This approach helps integrate different parts of personality that develop to handle various survival tasks, literally healing fragmented neural networks through therapeutic dialogue. For families, learning co-regulation techniques becomes essential. This means adults first regulating their own nervous systems before attempting to help children. When parents practice deep breathing, their children's heart rate variability improves, a measurable sign of nervous system regulation. The most powerful intervention is what researchers call earned security, consistently providing the attuned care that was missing during critical developmental periods. This doesn't just change behavior, it literally grows new neural pathways and can even reverse some of the structural brain changes we discussed earlier. Nutritional neuroscience also plays a crucial role. Omega-3 fatty acids support neural membrane health, magnesium aids in nervous system regulation, and probiotics influence the gut-brain axis, which affects mood and stress responses. Research from the National Institute of Mental Health shows that with appropriate interventions, children can show measurable improvements in brain structure and function within 8 to 12 months. But healing requires more than individual intervention. It demands systemic change. Individual interventions, while powerful, face an uphill battle against systems designed to stress developing brains. We need a public health approach that treats childhood brain protection as seriously as we treat physical safety, because that's exactly what it is. Educational neuroscience is revolutionizing how we think about schools. Finland's education model isn't just progressive, it's brain-based. Children don't start formal academics until age 7, allowing crucial play circuits to fully develop first. Recess isn't optional but neurologically mandated, with 15-minute breaks every 45 minutes to allow prefrontal cortex recovery. Research from the University of Helsinki shows that Finnish children, despite later academic start, outperform their globally earlier starting peers by adolescence. Their brains had time to build proper foundations before adding academic load. Workplace neuroscience reveals how parental stress directly impacts child brain development through what researchers call stress contagion. Companies implementing brain-healthy policies, flexible schedules, mental health support, parental leave, aren't just being nice, they're protecting the next generation's neural architecture. Technology presents unprecedented challenges to developing brains. Social media algorithms designed to capture adult attention wreak havoc on children's still-forming attention systems. The anterior cingulate cortex, crucial for focus, becomes dysregulated by constant notification-driven stimulation. We need neural protection policies treating developing brains as uniquely vulnerable to digital manipulation. Community-based interventions show remarkable promise. Programs like trauma-informed neighborhoods train entire communities to recognize and respond to signs of childhood toxic stress. When bus drivers, store clerks, and neighbors understand child brain development, they become part of the healing network. Economic inequality remains the largest systemic threat to child brain development. Poverty doesn't just affect resources, it creates the chronic stress that literally shrinks developing hippocampi and disrupts prefrontal cortex maturation. Universal basic income pilots show measurable improvements in children's stress hormone levels and academic performance. Healthcare systems need pediatric mental health integration. Primary care physicians should screen for parentification using validated tools, just as they screen for physical development milestones. Early identification could prevent decades of neurological consequences. The most promising systemic change is happening in juvenile justice, where trauma-informed approaches recognize that behavioral problems often reflect dysregulated nervous systems rather than character flaws. Brain-based interventions reduce recidivism by addressing root neurological causes rather than just symptoms. Cultural change requires redefining childhood success. Instead of celebrating the little adult, we must recognize that a healthy 8-year-old should be irresponsible, playful, and emotionally dependent on adults. That's not immaturity. That's optimal brain development. The question isn't whether we can afford to protect children's neural development. It's whether we can afford not to. We've reached the end of this neurological journey, but in reality, we're standing at the beginning of a brain protective movement that could reshape how humanity treats its most vulnerable minds. Today, you've discovered that parentification isn't just harmful behavior, it's measurable neurological damage. We've seen how survival mode hijacks developing brains, creating structural changes that persist for decades. But we've also learned that the same neuroplasticity that allows this damage also holds the power for healing. You now possess the knowledge to recognize neurological signatures of parentification, the hypervigilant scanning, the fragmented sleep patterns, the chronic muscle tension of children whose brains are operating in survival mode. More importantly, you understand the brain-based interventions that can literally rewire these patterns. But this knowledge comes with profound responsibility. Every child you encounter now represents a developing brain that deserves protection. Every mature child you meet might be silently screaming for someone to notice their neurological distress. The science is clear. We need systemic change that treats child brain development as a public health priority. This video reaching more people isn't just about views. It's about creating a critical mass of adults who understand that protecting childhood isn't sentimentality, it's neuroscience. Share this video with parents, teachers, healthcare providers, policymakers, anyone who influences a child's life. Comment below if you recognize these patterns in yourself or children around you. Your story might be the catalyst that helps someone else seek help. Subscribe and hit the notification bell, because every week I translate cutting-edge neuroscience into actionable knowledge that can literally save developing brains. In the description, you'll find resources for trauma-informed therapy and organizations working to protect children's neurological development. Remember, a brain protected in childhood becomes a mind that can heal the world in adulthood. The future of human consciousness depends on how we treat developing minds today. The neuroscience revolution starts now. It starts with you.